Our last speaker before the afternoon keynote is no less impressive than the others, contributing to both open source projects and building end-to-end machine learning solutions. He's currently a distributed systems engineer at Rotational Labs, joining us to talk about optical character recognition. Folks, please recognize Patrick.
Thank you. Hello, everybody. So I'm allowing myself one AI slide, so this is it. And we're done with that. So yeah, I work at Rotational Labs. We have been building AI systems for the past 5 years for very specific applied solutions. And so this is the team. So in this talk is going to be focusing on OCR and then text extraction and how to achieve that with modern systems. So first I'll start. Does anybody know the first OCR system? So I had to look this up. Apparently it is the optophone in 1913, which used photosensors to detect printed text and convert it into a time-varying frequency. So basically what that means is that I think they would slide a thing over printed text, and then they would spit out a frequency that people who were blind could actually interpret. And so it was kind of an alternative to text that was not already in Braille, and allowed them to, essentially it's just like an accessibility tool, which is pretty cool. So I guess I would consider this kind of like analog OCR. So it's spinning out an analog thing, but it is still the act of turning something which is unstructured into something that is more structured that we can understand and comprehend. So another hot take. This is 90% of software engineering is just turning something that is unstructured into something that has structure in it. So obviously I'm being a very little glib here, but I do think that even though JSON can be unstructured, it's definitely a lot more useful to modern applications if we can extract structure from data which kind of exists in this unstructured space. So that's where OCR kind of fits into the picture. Structured extraction is relevant for basically any software system because we need structured data to make decisions. And there's a lot of applications in various domains. So a lot of companies are trying to modernize by turning their documents into digital documents, and even for stuff like RAG and LLMs. Information extraction from human filled documents. So if you have humans filling out forms, even if they're digitally filled out, sometimes they're images, and then you just need to turn those into things that you can actually run through a system, and making modern systems more accessible to all kinds of users. And so OCR, we're specifically dealing with extracting structured information from images. So this is the example that we're going with today. I just created this receipt from makereceipt.com, and you can just make all kinds of different receipts for testing. So if you want to try this at home, you could do that and then test some of these models out. So what we have is like a picture of a receipt, and then I just scribbled in some handwriting there to make sure that we can capture handwriting. And then we have some magical OCR system, which is going to take that and spit out receipt.json, which is mainly what we're interested in capturing. So this is the typical extraction pipeline. If you've done any computer vision, you'll know the first step is usually pre-processing. So it's taking images, making sure that they are standard formats, possibly converting to black and white, and removing artifacts, resizing, all that stuff happens. And then we have an extraction piece, which is extracting text from the image, which is the real OCR piece. And then the parse step is probably a step that maybe gets overlooked, but it's probably the most important because that's where we actually take the text data and convert it to a structural format that we can actually use. So I'll go through some of the traditional OCR techniques. The modern models are mainly based on the transformer architecture, which you may know from things like ChatGPT and all the other AIs. So you don't have to know what all of those blocks mean, but basically know that that's the basic transformer architecture. Some of these models are small enough that you can run them on CPU on your laptop that doesn't have a GPU on it. And you can train them for specific targeted use cases. If you have a specific data set that you want to train on, like receipts, you can do that. So that is like the kind of like the entry level at this point for OCR models. So I'll walk through a few of the libraries that I've used. So Doctor is one that is orchestrating in a two-stage process. There's a text detection and then there's the text recognition. So you can think of it as if you're looking at each of the fields and then detecting bounding boxes. And then the next step is to take those bounding boxes and turn them into actual characters, which becomes the text blocks. So that's what Doctor does, and you can supply the specific models that you want at each of those stages, or you can just use the defaults. But that's what Doctor is, in case you encounter that. Docling is a bit of more high-level implementation. So they're actually going beyond that, and they're just treating everything like everything is a document, and then they have an intermediate representation, which they convert all those different input formats to in order to do the OCR, and then you can export to whatever format that you need. So if you need like a dictionary format, or if you need just a markdown, you just have this hooked up to some user-end system, you can do that. And I think there's actually a tutorial about that tomorrow, so not by me, but by somebody else, which you should go to if you're interested in Docling. So that is Docling, and this is an example of what that looks like if you run that through, run that receipt through Docling. You get this, I would call it a semi-structured output where it's identifying the pages, blocks, lines, words. So you could theoretically take that information and extract what you need from it. The important part is we have all those fields extract, or the characters extracted. So the OCR part of that is kind of done. Now, if you're actually applying these models, you'll quickly realize that it takes a bit more work to actually get what you want, because the business use case is probably just not. We need to know what's in this text, what's in this image. It's more so we need to capture like what are all these things that this person is buying in this receipt, and what's the total, so we can submit that to reimbursement or whatever, and then. So it's like 3 lines in Python, but actually extracting structure from that can be a bit more complicated. And it's very, no matter what you do, it's going to be very fragile because you have to make assumptions about how the fields are actually appearing. And then if you look like this example, all of the prices are on the same line, which is kind of annoying because you usually process text files like line by line and not like column by column. But in other use cases, it could be the other way around, so you have to handle both cases. So that it just makes it a bit more really complicated and involves a lot of trial and error when you're trying to develop these systems. So I think that's part of the reason why people are starting to go towards the LLM route with the text extraction. And so now we'll talk a little bit about the LLM side of things, which is the more current way of doing this. So VLMs. So this is like a generative solution to text extraction, meaning that we are generating text instead of simply extracting it. So we're taking usually take a prompt and then supply an image to a multimodal model, and then we're hoping that we get some good result back with the JSON that we want. And so these would be things like Claude and Gemini that I'm sure a lot of you have used before, which can take multiple different formats. I want to talk about pydantic schemas, because this is where having a schema really becomes useful. So pydantic is a library which you may have used before if you've developed an API, like a fast API, because I think it's integrated with that. Instead of just HTTP API, this would be more like an extraction API. So we're defining the schema that we're actually extracting from the receipt, and so we can just declare it in terms of the fields that we want. And so I have each item is an object, and then the receipt is like a list of items and a bunch of other data on here. And what I do like about this is that this forces you to kind of sit down and understand what data you're actually extracting, and then make validation constraints on it. And then the descriptions are also useful, because not only is that kind of telling you what the field is if you're just looking at this in code, it also you can also use that information when you're dumping this to dumping the schema. So if we're just doing schema text extraction with Hugging Face transformers, you can dump the schema directly from the model. So here on that line, I'm dumping the schema there, and that creates a JSON schema. And then we're just injecting it into the prompt. And then most of the models that I have tried are able to understand that pretty well. And then it has all the contextual information so that they actually know what each field means. Now, the alternative way of doing it is that most APIs right now, you can just pass in the pydantic schema. Like in the Anthropic API, you can just say, this is the output format, and then give me the parsed output. And then, so they've kind of wrapped that implementation at this point, and that should output the object for you. So I'll talk about some of the problems with the VLM approach. Obviously, hallucinations, confabulations, is that without proper context, the VLMs tend to mix up certain fields. Like this is a real problem that we encountered, was that we're trying to extract an address, but we actually have two fields for it. And I guess we could argue whether or not that was a great decision to have the two fields separate. But nevertheless, it's a little confusing of what where the suite or apartment number is supposed to go in those two fields. And then also when you're dealing with multimodal models, it's just a lot more difficult to work with images than text because of the cost that you're taking on just sending the images to Claude, and the results can be more inconsistent since if you're dealing with image data, there's a lot more entropy in how those models will respond to what's in the image. This is where the hybrid approach comes in. So this is where we're actually using both a doctor type OCR extraction, which is a smaller model, and then we're using the Claude to just make sense of the results. And that tends to be a pretty good option, because what we're doing is that we're grounding the results in terms of the text that we actually extracted. So that means that once you've extracted the text and parsed it using the LLM, you can go back and say was this field actually in the OCR text or not? And if it's not, you can flag it, or you can mark the confidence score or whatever you have to do to make sure that you're not really sure if that field is correct. So basically what this is like a task decomposition, and you're decomposing the OCR part from the parsing part and making it easier to debug each stage in your pipeline. So now we'll talk about probably the most important part, which is evaluation. So every model that you deploy should be evaluated. And this is kind of the methodology that we've been following, is that there's kind of three phases to this. One is the schema creation. That's where you're defining the Pydantic schema, and then you can create the test cases from the schema. And then the experimentation phase is that we're defining two experiments, and then we're using that to compare against each other and then produce the results. And then we have an evaluation step where we look at the results and say which one is better. But the key here is that the schema is used like in all three phases. So that is basically the first step. So I've talked about the Pydantic schema before. It just represents the contract between the extraction and the outside business application. So that's important to basically get right out of the gate because it informs both of the following steps. In terms of test case creations, this is where you're actually like going and creating a bunch of test cases in the case that you don't actually have real data, which is probably most of the time you don't have real data when we're working on these, trying to develop these things. So what this does is that you can create a ground truth JSON, then you can also use that to generate the thing that actually goes into the input for your test cases. So Faker's good library for this because it just allows you to create a bunch of test cases really cheaply. So here I'm just, I like to do it by adding a class method here. So you can just go item.make example, and then that just creates the new example for you. And that will just, you can do this very cheaply because there's no LLM involved here, just like a library that just kind of takes a bunch of strings from lists and then puts them together. So I've created a new, I guess, a new dish here, a new item on that recipe menu. And when you're defining effective experiments, you should be modifying as few variables as possible to make sure that your experiment is meaningful and you can actually draw conclusions from it. So you could choose two different models with the same prompt and the same model parameters and sampling parameters and say which model is actually better here to use for this specific use case. And then you would run both experiments against the many test cases you have and get your evaluation results. So in terms of evaluation, with OCR, like the main starting point is correctness. So here we're comparing the two JSON outputs, or the ground truth, to like what the model actually outputted. And you can see that, oh, there's an error here. And then we could look and see, did that actually come from the OCR extraction, or did that come from the parsing step? And so the one thing that I want to mention, which is pretty important, is that accuracy is not the only metric. So it's like the metric that is the most obvious, I think, but there's also a lot of other metrics that might be valuable for your use case. Like, for example, readability. If you're generating text, anytime you're generating text, like making sure that it's readable, and that might be in a different in many different ways to compute that. You can use the Flesch Kincaid scores, which is like basically the analog of the grade level. If you're concerned about users that are actually reading, that's more for like generation, not necessarily extraction, but might also apply here. And then cost. So there's actually different ways you can break down costs. Like there's the cost of inference, and there's the cost in terms of dollars, and then time, so latency and how fast you're able to process all of the receipts or images that you have. There's also energy costs for using LLMs, so you could compute that as well from the tokens that you're using, and get an approximation of like how much energy is the system actually using. Do we want to use this much energy for this task, and like, can we get away with using smaller models that aren't the giant VLMs? And then there's styling too. So when you're outputting JSON, it's not necessarily going to be standardized because it's a string. So even if it's JSON, it might have different indentations and field names that will need to be make sure that it's abiding by the style that you expect from the output. So in terms of evaluation, what we've realized by creating solutions is that, like, at some point, you actually just need to dive in, look at the results to make sure that the generations are correct and that the system is working how you expect it to. So eventually, you come around to the idea of an evaluation app, and we've created a few different apps along the years that we've been doing this for different problems, and then it just always like happens where you need to be able to create something to investigate, to look at, to see what is happening. So this is like kind of an example, like maybe what you'd want to have, where you have the model output, and then you could also see what prompt went into it, and then being able to easily identify mistakes is pretty important, instead of just having to like comb through a JSON a .csv file or something like that. And then a way to submit feedback, also important in terms of capturing both like the automated feedback that you can compute, and then also for user feedback. So if you have like clients that you're working with and they have some specific needs, that would be a good way to introduce kind of this feedback loop at a very early point before things get out of control. And so that's kind of like the full workflow. So we're basing things off the schema, and then that kind of drives the entire evaluation process going forward. And then leave you with a few takeaways here. So OCR, I think in terms of like if you're technically rating what OCR is supposed to do, it's like mostly a solved problem. But the harder problem I think is like structured extraction. That's getting like getting structure out of unstructured data is like kind of like the fundamental issue here, and that just requires like defining schemas and making sure that your evaluation mechanisms are what are going to drive you to the right outcomes you want. I would say that smaller OCR models from my testing are very effective at text extraction. And I do like the hybrid approach, just being the task decomposition, being able to debug what's happening on each stage of the pipeline is good. And evaluation mechanisms are very critical to deploying OCR systems. If you define the schema first, that goes a long way in terms of both communicating with your client or whoever you're delivering this model to, and making sure that you're meeting your evaluation metrics. And then the last thing is that we actually built our own tool for LLM evaluation, which it's in early access now. So we're excited to see like what you guys think of it. We're open to any feedback because I mean that's why we opened it in the first place. And with that, I can take some questions. I think we have time for questions, right?
Yeah, we got about 5 minutes.
All right, awesome. Yep.
So in the hybrid approach that you shared, I think you listed specifically using .tr and then Opus, Quad Opus. Why Opus and not like Sonnet? And then, like, given that you're able to actually evaluate this, how much better does Opus perform than Sonnet or other models?
Yeah, so the question is about, we're using Opus in one of those slides to demonstrate the hybrid approach. And the answer is I just picked a model to put there in the slide. And like, you could use any model there. In fact, like, I encourage like experimentation and not just assume like this model is going to be good because they say it on the that it's good at doing this specific thing. Like these things need to be experimentally verified, especially if you have specific use cases like processing receipts, or if there's handwriting or not in the receipt, and there's all different variables that you need to account for. So thanks for your question.
Do you have any experience with using LLMs to like correct any like mistakes that like the hybrid approach, like say doctor has some mistakes, but Cloudopus might be able to like take in contextual knowledge and kind of correct it, like if there's a clearly made a mistake, and like your LLM has more knowledge of just what the context of the data should look like.
Mm-hmm.
Any experience with it kind of like retroactively correcting the like OCR, like if the OCR readability is lower, and then using context?
Yep. Yeah, so that's a good question. The question was about retroactively correcting LLM mistakes using like a secondary LLM, and that's definitely a very valid approach. I think people will use an LLM evaluator like at like this later stage past this Cloud Opus stage to check and verify that everything, all the fields were filled in properly. That's certainly a way that you can solicit like feedback, because that LLM will have different context than the one that you originally sent the prompt into. So yes.
So in your OCR example, so there's layout information on that.
Mm-hmm. Yep.
And in your first example, the OCR kind of ignored the layout information, sort of jumbled it up. That was in one of your earlier slides.
Yes.
I don't know if that was .tr or a different.
Yeah. So I think what I did here. Oh, sorry.
Well, it's kind of a three-part question. That was
Yep.
some context. So given that, what is the VLM doing with the layout information that gets it a better result?
Mm-hmm.
And then part three is, in your hybrid slide that you were just showing, it seemed like the input to the LLM is this jumble on the right. So how does that improve? How is that better than just throwing the LLM at the receipt where the image where it can use the layout information?
Yeah. So the question is about how we're passing the data to the LLM in the hybrid approach, whether or not we're using contextual like bounding box data and positioning data. And for this example, I just sent it in as is, and then it did happen to work in this example. But you can also, I think I have an example somewhere where maybe I don't have like the full output here, but basically I think the doctor model does give you a lot more positioning information, and you could send that into the VLM as well. And so that approach is basically you're figuring out the bounding information up front, which is using a different approach than if you were to send it to a VLM directly. So the VLM is fundamentally different, processing it differently. Like it's not actually going and figuring out the bounding boxes. It's just doing a very high dimensional math there to figure everything out. So I would suggest trying both approaches to see if like including bounding box information will actually improve the results, and that would be one experiment that you would run.
I think we have time for one more.
Is Doctor the best OCR model you've found, and could it integrate with DocLink?
Okay, the question is Doctor the best OCR model that I've encountered, and could it integrate with DocLink? So I think Doctor and DocLink are trying to solve the same problem. I don't want to give any recommendations about like a particular model because it depends on the use case. But what I would say is that Doctor is definitely like the output is different. So I think it depends on whether or not you need to export to different formats, or if you're just okay with parsing the results of what Doctor gives you. And I'll say that both of them are they're both wrappers. They're basically both like high-level wrappers around transformer models. So if you know what models they're using, you could just execute those yourself, but it just takes a bit more code in order to do that. So.
Alrighty, another round of applause, please.